Hello everyone, I'm Nancy Mary Vanessa presenting a project of AI of tax transportation. A brief description of the project and why it matters. The transportation industry is inefficient and unreliable, thus leading to a wastage of time, resources, and delays in our daily lives. This project matters because 85% of the total population in our country are always moving or transporting goods and services. Therefore, the inefficient transportation system causes risk of many issues, which may be loss of life in case the means of transportation being used to move someone from a specific destination to a specific place to another. It also leads to wastage in terms of resources that are being used in case they are delivered late. Therefore, this brings in the need to use AI to improve the efficiency. How AI will be used in this project. AI will be used to figure out the shortest distance to take. This can be done by using online maps. It will also allow individuals to predict the route with less congestion in order to use the minimum time possible to their destinations. This can be in case someone is moving from Kampala, like from Kampala to Kawanda. Those people can go online, then the AI will direct them to a specific route that has less congestion or jam. This will also enable individuals price the customers according to the distance moved. This works for the case of the drivers. Therefore, there won't be like conflicts among the drivers and the customers, since the AI will automatically determine the fares for the customers. This will allow individuals to predict areas with high concentration of customers, thus reducing on the customer waiting time. The AI will help like drivers know the places where there are lots of people or customers so that they can go and pick them up from their waiting points. And this will reduce on the time someone spends at a specific place. The types of data to be used. We have distance. Distance will be like numeric data. Like it will be calculated. So you can use a map to calculate the distance from one place to another. Also, we shall use time. The time moved from the time of the pickup point to the destination. Also, we will need prices, and these are values. And prices can be in terms of the prices of the fuel used. Someone can say, I've moved from Kampala to Kawempe. I've used this fuel, and it will also help people to know the fares. Then we have the differences between supervised and unsupervised learning. Like supervised learning, it's where we teach a model using datasets. Like datasets are given by the raters. The raters can be an individual or like an inspector who is doing something. So for supervised learning, we have raters and labels. Raters are the people who are specifying in a given thing. For example, a doctor, you have your data, and the data sets are the specific specimens being used. So, and unsupervised data, it doesn't use labels or data sets. For it just employs the use. It doesn't need any supervision, so there won't be any need of raters and data and labels for the data. The first difference is in supervised learning, input data is provided to the model along with output. But for unsupervised, it's only input, but the output is not provided since there is no much supervision to follow up the data. In unsupervised learning, it provides accurate results since someone will be following up on the datasets to see any changes. While for unsupervised, there is less accuracy in data since there is no consistency. supervised learning algorithms are trained using labeled data. That's what we have said, that someone will know that I assigned medicines to a specific number of people, like 5, and I follow up and say, among the 5, how many like were well after taking the medicines. But for the case of unsupervised, we don't use data sets, or they are unlabeled, in that there will be a challenge of knowing what exactly happened. With supervised learning, it needs supervision to train the model. There will need someone to be there to train the model, but for unsupervised, it does not need any supervision to train the model. Supervised learning model predicts the output, since someone will follow up. Unsupervised learning models find the hidden patterns in the data. Then supervised learning models take direct feedback if it is predicting correct data or not. For supervised learning, we shall know that the predictions being made by the model, are they right or wrong? But for unsupervised, the model does not take any feedback. Then we have the supervised learning techniques, which include regression. This is used to predict behavior of one variable depending upon the value of another variable. The result may be numeric, like where are we applying this technique in this project? According to this project, the variable can be distance moved from one place to another in a given area. And we are comparing, since we are comparing two variables, the other variable can be time. There, we compare the distance moved and the time taken from the pickup point to the destination. Then we can use the decision tree. This is a decision support tool that uses a tree-like model of decision, and there are possible consequences. This is one way to display conditional statements. So we're going to look in this project and know where we can use the decision tree. According to this project, this can be used to determine the most reliable route in case of changes in the weather. Yeah, you can know if it's sunny, it's better someone uses this route, and if it's rainy, you can say it's better someone uses the other route. Then we have also unsupervised learning techniques, which include clustering. Clustering is a way of grouping the data points into different groups consisting of similarities. For clustering, we group data according to the resemblance it has. For example, it can be in terms of shape, size, the behavior. So according to this project, datasets can be vehicles or like Ubers, because we are dealing in transport. And the groups can be done according to their unique features. For example, we can group cars according to the speed. We say, like, for example, we say this Uber moves faster than the other. So we group Ubers that move fast in one group, and also we can group them according to their sizes. This ensures that each data set has a unique attribute. Then we have the association learning, it's a role-based machine learning and data mining technique that finds important relations between variables in the dataset. This can be applied to this project by defining the attributes and features that are common amongst all the datasets that we are given. Like, we have the AI challenges that can be encountered during this project. The first challenge can be the bias problem. The AI system depends on the data that they are trained on. When producing results based on distance as assumptions, such biases must be eliminated, since an individual would like to use prices, thus leading to discriminate amongst particular groups. Like the bias problem, the model will consider only the data that it was given during training. So if anyone else tries to put in another type of data, it will be consistent. It won't change as the person has given it another data. It will remain on the old one. Poor traffic prediction. This is where the model predicts the route. A model predicts a route that does not have congestion. This may be due to uncertainties in weather. For example, here, a model may say that a given area does not have traffic, but our model is not trained to go with weather changes. So it may predict the place doesn't have traffic and it rains. So traffic increases and someone goes to a given area hoping and thinking that there is no traffic, yet it's there. Also, another challenge is difficult in determining the right data sets. This is where the data input into the model is not from a trusted source or a reliable source, thus causing inconsistencies. Solutions to the above problems. The bias problem can be solved by increasing on the data sets while training the model. Like the traffic prediction problem can be solved by using congestion propagation patterns, where the AI will provide routes to specific areas that have limited congestion or jam. Difficulty in determining the right data can be solved by using data from trusted sources with reliable information. Accuracy versus recall versus precision versus F1 score. Accuracy, this is the most inquisitive performance measure, and it's the simple ratio of correctness predicted observation to the total observation, whereas recall is the ratio of the correct predicted positive observation to all observation in an actual class. Whereas precision, this is the ratio of correctly predicted positive observations to the total predicted positive observations. And F1 score, this is the weight average of the precision and recall. This accounts for both sides, which are to say the negative and the positive side. An evaluation matrix. It can be the classification accuracy. This is the ratio of the number of correct predictions to the total number of data sets, which is used to determine the accuracy. Like classification accuracy, it's used to determine the rate at which the model that has been created is accurate. And we have a confusion matrix. This gives the matrix as output and describes the complete performance of the model. This involves use of individuals to test the model. And here I've given you some references to the sources I used for my presentation. Please like and comment. Thank you.